Okay, this problem is pretty gnarly. It has a lot of information. And then we have like all this stuff right here. Like when I first read this, I'm like, man, how am I going to graph this thing? And then I read A. A says, create a scatter plot of data with the horizontal axis representing time. Do you guys know which way is horizontal?
God darn it.
Yeah, okay, so that means this axis right here is going to represent time. And I would label it if I were you. And then it says time since May 21st. Okay, time since May 21st. Here's May 21st. Okay, so that means the beginning of May 21st. When does a day start?
12 a.m. Midnight.
At midnight, which is 12 a.m., right? Now, if you are doing military time, that's 0000, right? Okay, but they give us the first data at 0247. Okay. So we'll work on graphing that right here in a second. Let's talk about the vertical axis. The vertical axis is representing the height in feet. The height in feet. Okay, so this is what's happening, people. We're taking this data, and we're going to graphify it. We want to represent it as a graph. And so we're going to make these the x's and these the y's. But let me tell you to do something right now that would make this super easier, okay? We're going to make all of these into military time.
Oh my god, that's beautiful.
Okay, so here, let me do this little thing right here, get rid of that. All right, so here we go. This first one, no problem, it's 0247. The next one is 0946. And then we have PM. That changes things. When we're in the PM, you take the hour and you add 12 to it. What is 3 plus 12?
15.
So this is 1531. And then this next one, what's that one going to be? Add 12 to that.
That's
22, 20. And then add, okay, wait a second. Now I'm back at AM. But I'm not going to write 0350 because the X is supposed to represent the time since
So you keep going.
000, which is 12 a.m. midnight on the 21st. And so what am I going to add to 350 to find out how many hours passed? Here, think of it like this. Start at 10
And then count up.
and count hours until you get to 3. What do you get?
5.
So you added 5 hours?
Yeah.
So we would add 5 hours to this one?
5 hours.
Yeah.
30 minutes.
Okay, the other way to think about it, the way I'm going to do it, is when we changed to PM, we added 12 hours, right? When we change back to AM, we're going to add 24 hours. So what is 24 plus 3? 2750. And then what is 10 plus 24? 3441. Okay, now we're switching to PM, so now that means we have to add another 12 hours. And so instead of adding 24, I'm going to add 36. What's 36 plus 4? 40, 35. And then 36 plus 11 would be 47, 23. Okay, if we have all those, graphing becomes way more simple.
Oh, that's easy.
So now we're going to use those times for these. Because this time, these numbers just keep counting up. Because this 44 represents 44 hours from midnight on the first day. Okay? So let's graph those really quick. First x value?
0,
2, 4, 7. And then what's the y value? So I'm going to go right about here. What's my y value? 2.4. So I'm going to put a dot right here. Okay, what's my next point? 9. And then we're going down to negative. So it's like, what is it? Negative. Okay, so we're right here. So there's my dot. Okay, and what's my next number? My next x value? 15. So we're right here. Okay, and then what are we going to go up to? 2.3. So whoop, we're going to go all the way up to here and put our dot. Okay, let me do the rest of this really quick. Okay, after you graph all those points, can you guys guess what kind of function this looks like? Looks like a sinusoidal function. If I connect them and try to make it curvy, This is what I got. I mean, it's not perfect. But that's definitely sinusoidal. Okay, now I don't want to move away from my screen because I want to use the graph to talk about the other ones. The letter B just asks you what type of function this is. That's sinusoidal. Look at letter C. Letter C says, can we find the midline, amplitude, and period?
Yes.
Here, let's estimate a midline. I'm going to try to find the middle of this graph. I'm going to say, does that look like the middle? Yeah, let's go with that. Let's go with 1.2. That looks good. That looks like the midline. That sounds good to me. What is now? We're just estimating. What is my amplitude? So what would that distance be right there? That looks like it's 2.4 almost. It's like right below 2.4, and this is 1.2. So what is 2.4 minus 1.2? Oh, it's 1.2. So my midline's 1.2. My amplitude is 1.2. And then the last thing is, what is the period? So I like to go from max to max. So if this is my max, and I go like this to this max, what is that period? What is the distance from here to here? This looks like it's 15, and this one looks like it's, what is that, 28? It kind of looks like.
13.
So what do I get? I go 28 minus 15, and I get 13. So 13 is your period. Anything close to 13 is good, because guys, this is a rough estimate, really rough. Okay, this one's saying, okay, it says estimate the horizontal distance between the point on the graph that crosses the midline. So that's this point right here to the point that crosses so this right here. So from here to here, you're supposed to estimate the distance between these two. I don't know. It's just asking. It probably has to do with frequency, but we haven't spent that much time on frequency. Yeah, don't worry about that. That one's not that important because we don't need that answer to do E. E is asking you to put in the A, the omega, the H, and the K. Now for the omega, just write 2 pi divided by whatever we thought the period was. 2 pi divided by that will give you the period. Wait. No, it won't. Here, let's see. What did we say our period was?
13.
13? Okay, if our period's 13, we have 2 pi. What does omega have to be?
13 times.
Let's see. We get 13 times W equals 2 pi. Oh, then we divide by 13, right? Okay, cool. So omega equals 2 pi over 13. So it is what I said. That's going to be the omega. Okay, and then your A is 1.2. The horizontal shift, ooh, that one's a tricky one. Maybe that's what this would help out with. The horizontal shift. And then your K, that's the easy one. That's the midline, 1.2.
Is there a horizontal shift?
I think I would just say that this function is sine. Oh wait, no, yeah, I would say it's sine. That way I don't have to worry about a horizontal shift. So you could say H equals 0.
Jeez.
Yeah, that's nicer. So what would I have? I would have 1.2 sine, and then my omega is 2 pi over 13 x, and then I'm shifting up 1.2. This is an estimation, people. It's not exact.